Bismillahirrahmanirrahim. In the name of Allah, the most beneficent, most merciful. Dear students, I am Dr. Asrar Ahmad and it's my lecture number 6. This is related with the thermodynamics of redox reaction. Dear students, this topic belongs to the course Advanced Physical Chemistry of the code CHEM 3117. Dear students, during my previous lecture I have discussed that in the galvanic cell, chemical energy is converted into electrical energy and electrical energy is converted into chemical energy by the electrolytic cell. Dear students, the question is that what is the relationship between electrical and chemical energy? Because electrical energy is produced due to the flow of electrons, while chemical energy is produced during the redox reactions. So redox reaction means reduction and oxidation. Oxidation at anode and reduction at cathode. So in order to understand their relationship, we have to study the basic concepts of thermodynamics. So when we will apply the principles of thermodynamics, then we will find different relationship between entropy, free energy, and other thermodynamic parameters. Dear students, for the large number of reactions, it has been observed that electrical energy produced is not equal to the chemical energy. In actual practice, electrical energy and chemical energy, when they are converted into each other, then they should be equal. But there is some observations that when electrical energy produced, it is not equal to the chemical energy. So this suggestion, as in 1875 by Gibbs and 1882 by Helmholtz, that electrical energy produced in the reversible cell is equal to the degrees of free energy accompanying the cell reaction. It means when electrical energy is produced in the reversible cell, then the difference from the chemical energy, it will be equal to the free energy. So they found a relationship between both energy. So according to the finding of scientists, the relation between electrical energy and quantity of electricity has been found in the form of equation number 1. According to equation number 1, electrical energy is equal to quantity of electricity into electromotive force. So this relation is very important for the next lecture, because in this equation number 1, we have found a relation that electrical energy is equal to product of the EMF and quantity of electricity. So dear students, if we suppose that EMF of the cell is capital E, this capital E may be electromotive force, you can say it is the electrode potential, then electrical energy will be equal to N into F into E. Dear students, according to equation number 2, this N is the number of electrons that will be transferred from one electrode to the other, while F is the Faraday's constant and capital E, it is the electromotive force. So dear students, if we represent that change in free energy, and that is the useful form of work that has been done by the system, then we can represent it with del G. This del G is the change in free energy. So this change in free energy del G, it will be equal to NEF. So NEF will be equal to minus del G. This indicates that decrease in the energy. This minus indicate decrease in the Gibbs free energy. So according to equation number 3, this minus del G is equal to NEF, and there is a very important equation from thermodynamics that was proposed by Gibbs-Helmholtz. So it is called Gibbs-Helmholtz equation, according to which del G, change in free energy or change in Gibbs free energy, is equal to del H plus T into partial del G over partial T at P, constant pressure. Dear students, here del G is called Gibbs free energy, change in Gibbs free energy. Del H is the change in enthalpy. And what is enthalpy? Basically, enthalpy is called the sum of the internal energy and pressure volume work. Enthalpy is the sum of internal energy and pressure volume work, while T is the absolute temperature, and this partial del G over partial T, this indicates that a change in Gibbs free energy at constant pressure with respect to change in temperature. So dear students, according to equation number 4, we can relate change in Gibbs free energy with the change in enthalpy. So dear students, if we put this value of del G from equation number 3 in equation number 4, this is equation number 3, this is equation number 4. So dear student, we will just write this NEF here. So this NEF here, it will become like this: minus NEF is equal to del H plus T into partial minus NEF. This NEF is equal to del G over partial T at constant pressure. This P indicate constant pressure. So when we will rearrange this equation, then dear students, we will find equation number 5. Dear students, according to the equation number 5, just by rearranging the above equation, NEF is equal to minus del H plus NF T into partial E over partial T at constant pressure. Dear students, because electromotive force is a variable quantity, so here N and F, these should be the constant because F is Faraday's constant. So dear students, according to this equation number 5, we can say that enthalpy change del H or chemical energy of the reaction depend upon the temperature coefficient of EMF, and this temperature coefficient of EMF is equal to partially over partial T. This term is very important. We will discuss it in the next slide. So, temperature coefficient, that partial E over partial T, is the rate of change of electromotive force of the cell with respect to the temperature. Again, I am repeating the sentence that temperature coefficient is the rate of change of electromotive force of the cell with respect to the temperature. So dear students, we can draw the following important conclusion that if we divide equation 5 by NF, this is equation 5. If we divide with NF, N will be cancelled, F will be cancelled. Here will be remaining amount capital E, that is the electromotive force, and this will be minus del H over NF plus N and F will be cancelled, T into partial E over partial T at constant pressure. So dear students, this equation number 6, this equation is very important, because with the help of this we will find the change in entropy. So dear students, before going to the other thermodynamic parameters, first of all we have to discuss this temperature coefficient, that is partial E over partial T. What is the meaning of this term? Dear students, meaning of partial E over partial T is the rate of change of EMF of the cell with respect to the temperature. The rate of change of EMF of the cell with respect to the temperature. Dear students, if the change of temperature does not affect electromotive force, then this temperature coefficient will be 0. If there is increase of temperature, then electromotive force will increase. So this partial E over partial T will be positive. Similarly, if increase of temperature decreases the electromotive force, then this temperature coefficient will be negative. So it means that temperature coefficient may be 0, may be positive, may be negative. Dear students, from here we can have the following conclusion. Number 1, when partial E over partial T is extremely small, it means it is very close to 0. If this partial E over partial T is very close to 0, then electrical energy NEF will be equal to change in enthalpy. Conclusion number 2, if the partial E over partial T is positive, then electrical energy produced will be greater than the heat of reaction at constant pressure. It means that the additional energy will be absorbed from the surrounding and the reaction will be endothermic. Similarly, when the partial E over partial T is negative, then electrical energy produced will be less than heat of reaction and additional energy will be absorbed by the surrounding. So dear students, following are the 3 conclusions that we can make with the value of this temperature coefficient partial E over partial T. Dear students, now in the next part of my lecture, we will discuss that what is the relationship between change in Gibbs free energy, change in enthalpy, and change in entropy with electromotive force of the cell. Dear students, here del G means change in Gibbs free energy, del H change in enthalpy. Del S mean it is the change in entropy. And what is entropy? Entropy is called the disorder of a system. So dear students, we have a very important relation that del G is equal to minus NEF. That change in Gibbs free energy is equal to minus NEF. This is the electromotive force. While N is the number of electron and F is the Faraday's constant. Dear students, from equation number 5 that we have derived earlier, we can say that NEF is equal to minus del H plus NFT into partial E over partial T at constant pressure. This is the equation number 5 that we have studied here. This is equation number 5. This one. This is NFT, NEF is equal to minus del H plus NFT into partial E over partial T at constant pressure. This is the equation number 5 from where we started the temperature coefficient. So dear students, this is the equation number 5. Now we will start the remaining part of lecture from this equation number 5. So dear students, to find out the relationship of del G, del H and del S with the electromotive force of the cell, we have found the relation that del G is equal to minus NEF. Del G means change in Gibbs free energy. N means number of electrons lost or gained. E is the electromotive force and F is the Faraday's constant. Dear students, if we put this value back in equation number 5, then it can be written NEF is equal to minus del H plus NFT into partial E over partial T at constant pressure. Dear students, if we rearrange this equation, then this part that is here, it can be written on the other side of the equation. So if we rearrange this equation, then we can write it in the form of equation number 8, according to which del H is equal to NF into T into partial E over partial T at constant pressure minus capital E. Dear students, in this equation number 8, del H, it is the change in enthalpy. N, number of electron lost or gained. F is the Faraday constant. T is the absolute temperature, while temperature coefficient partial E over partial T at constant pressure minus capital E. So dear students, this equation number 8 is very important to know the relation between change in enthalpy with the change in temperature coefficient that is related with the electromotive force of the cell. So if we know the values of N, F, T and E, then we can find that what will be the change in enthalpy of the cell reaction. Dear students, now in the next equations, we will try to find the relation of entropy. Dear students, from this equation, you can have an idea that we calculated del G, change in Gibbs free energy, from equation number 7 and del H from equation number 8. So this is equation number 7. Del G is equal to minus NEF. And this is equation number 8, that del H is equal to NF into T into partial E over partial T at constant pressure minus E. So dear students, we have the value of del G from equation number 7 and value of del H from equation number 8. So change in entropy, this change in entropy, it can be calculated from the following relationship that is given in the form of equation number 9. Del G minus del H is equal to minus T into del S. Del G minus del H is equal to minus T del S. This is the Gibbs-Helmholtz equation. And this Gibbs-Helmholtz equation tells us that del G minus del S is equal to T into partial del G over partial T at constant pressure. Partial del G over partial T at constant pressure, and this is the equation number 4 that we have studied in the previous slide. This is the equation number 4. This is called Gibbs-Helmholtz equation. So dear students, here if you say according to equation number 4, that is the Gibbs-Helmholtz equation, we can compare equation number 4 with equation number 9 because the left hand side of both equation is same. So both right hand side, they can be compared with each other. So if we compare equation number 4 with equation number 9, it can be written as minus T into del S is equal to T into partial del G over partial T. So dear students, if we see here that this del G is equal to minus NEF. So dear students, if we write this equation in this form, that minus T del S is equal to minus NFT into partial E over partial T at constant pressure, this T will be cancelled out with this T. So the remaining equation will be in the form of equation number 10, according to which del S is equal to NF into partial E over partial T at constant pressure. So dear student, in this equation number 10, you can find out the change in entropy if we know the value of electromotive force at the given temperature. So this partial E over partial T, this is called temperature coefficient. So in common sense, you can say that if we know the value of this temperature coefficient at constant pressure, then we can find out the change in entropy of the cell. So dear students, in my lecture, when I started, this is the thermodynamics of the redox reaction, that electrical energy is equal to quantity of electricity into EMF, and according to equation number 2, electrical energy is equal to NEF, and this del G is the change in Gibbs free energy. This can be arranged. So minus del G is equal to minus del G is equal to NEF. It is positive value. So we can say that if we apply the important thermodynamic relation, that is the Gibbs-Helmholtz equation in the form of equation number 4, it will be very easy for us to compare this equation number 4 with this equation number 9 here. So from these values, you can compare the right hand side, and from where you can find out the relationship between del S and temperature coefficient. So dear students, thank you very much. Take care of yourself. Allah Hafiz.